My name is Anubhav Shukla. My native place is Kanpur. I completed my Bachelor of Technology from NIT Calicut, Kerala. I am teaching physics for last 15 years. Today I will take a second year topic, which is alternating current. In alternating current, I will take a subtopic, that is analysis of RL circuits. So our topic is analysis of series RL circuits. As the name suggests, it is a series circuit. So there are two components, resistor and inductor, R and L, and they are connected in series. If I draw the circuit diagram, we have a resistor, an inductor, and they are connected in series, and an alternating source is connected across them. Suppose resistance of this resistor is R in ohms and its inductance is L in Henry. Suppose this applied source, its instantaneous equation is V is equals to Vm sin omega t. I am taking here initial phase of the applied voltage as 0. As in DC circuits, we can take potential of any one point as 0. Similarly, here in AC circuits, we can take initial phase of any one quantity as 0. Because phase is not important. Phase difference is important. As potential is not important, potential difference is important. So we can take initial phase of any one quantity as 0. So here I am taking initial phase of the applied voltage as 0. Now suppose these components draw a current I, instantaneous current I, whose RMS value is capital. Wherever I will use a capital letter, that represents RMS value of that quantity. So I is the RMS value of the current. Because they are in series, so the same current I will flow from both the components and it will return to the applied source. Now, when current will flow, there will be potential drop across these two components. Suppose potential drop across R is VR. VR is the RMS value of the potential drop across resistor. Similarly, suppose potential drop across inductor is VL. VL is the RMS value of the potential drop across inductor. And RMS value of the applied voltage is V. Now, in series circuit, we know that as we studied in DC circuits, if we add the potential drop across various components, we will get the applied voltage. It means If we add VR and VL, if we add, we will get the applied voltage V. But here is one difference. In AC, every quantity has magnitude as well as direction. They are like vectors. So we cannot add them algebraically. We have to add them vectorially. So I am putting vector symbol over them. VR plus VL equals to V. This is our first equation. Now, second thing is that to add these two voltages VR and VL vectorially, we will make phasor diagram to add them. So I am drawing phasor diagram to add VR and VL. While making the phasor diagram, we take one quantity as the reference quantity. Reference quantity means and generally we take the reference quantity which is common to all the components. Here in series circuit, current is common to all the components, so we will take current as our reference quantity. So we can take current in this direction. This is the current. I told you phase does not matter, phase difference matter. We can take any one quantity as a reference. If we take current as reference, it will make things easier. That is why I took current as the reference. Now we will draw VR. VR is the potential drop across resistor. Potential drop across resistor and current through the resistor, they are in phase. So if we draw VR will be in the same direction as the current I. So this is VR. If I draw VL is the potential drop across inductor which is 90 degree ahead of the current passing through the inductor. In case of inductor, voltage leads the current by 90 degree. So if I draw VL will be leading the current by 90 degree. So this will be VL. And we want to add VR and VL. As we know, if we want to add two vectors, draw the first vector, and from the head of the first vector, draw the second vector. Then join the tail of the first to the head of the last one, we will get the resultant vector. So this is VR. I will draw VL from here. This is VL. And from the tail of the first, join the head of the last, we will get the applied voltage V. This one. Now suppose this angle is theta, angle between the applied voltage and the current. Suppose this angle is theta. Here I drawn the directions of VR and VL and V. If now in vectors, if I want to write the magnitudes, VR will be equals to I into R according to Ohm's law. Resistors follow Ohm's law, so its magnitude will be VR is equal to I into R. Similarly, VL will be I into XL, where XL is the inductive reactance whose value is omega L. I am writing here XL is the inductive reactance and its value is omega L. Now, what information we get? This triangle which we get OAB. This triangle we call as voltage triangle. Triangle OAB is the voltage triangle. Now from this triangle we get many informations, such as first information is that it is a right angle triangle. So BR square plus BL square, this will be equals to V square. VR square plus BL square, this will be equals to V square. First thing. From this equation, if we know voltage, if we know any two voltages in this circuit, we can calculate the third one. So VR square plus BL square is equals to V square. So V is, from here, applied voltage V is under root of VR square plus BL square. If I put the values, VR is I into R, so it will be I square R square, and VL square will be I square XL square. If we take I square common, then I will come outside of the root and it will become I root of R square plus XL square. Now this quantity, which is coming root R square plus XL square, it is named as impedance of the circuit and it is represented by Z. So V is equals to, we can write I into Z. This equation is valid for all the AC circuits. V equals to I into Z. Applied voltage is equal to current into impedance. Here, for this circuit, value of Z is under root of R square plus XL square. It is called as impedance of the circuit. Third thing, this is the second thing, V is equals to I into Z. Now see, from the triangle you can see that here voltage V is leading the current I by an angle theta. So applied voltage V is leading current I by an angle theta. So if I want to write the equation of the current will be I is equals to Im means maximum value, I is equals to Im sine, here we took angle of voltage as 0 and current is lagging by angle theta, so its phase will be minus theta. It will be I is equals to Im sine omega t minus theta. Here voltage is leading or current is lagging, it means it is an inductive circuit. In inductive circuits, always current will lag and voltage will lead. Now, another thing which we can find from here is that we can calculate the value of power factor. Power factor is defined as cos of the angle between the applied voltage V and current I, which is theta. So power factor is cos of theta. From this triangle, cos theta will be base upon hypotenuse. Base is here VR and hypotenuse is V. Here VR is I into R and V calculated here, V is equals to I into Z. So I can now write here V is equals to I into Z. So VR is IR and V is IZ. I cancels out, so it is R by Z. So from here we can calculate the value of power factor. Another thing, see here, this V is like a vector. if we take the component of this vector v, we will get horizontal component as Vr. And this component we can write as V cos theta. Component along with the angle is in cos, so this will be V cos theta. So we can write as Vr is equals to V cos theta. And if we take the vertical component along y-axis, this component is VL and this will be VL is equals to V sin theta. This is the relation between the different voltages and the angle theta. So this much information we get from the voltage triangle. Now we will talk about the impedance of this triangle. For that we will make impedance triangle. Now I'm removing this part. Impedance triangle we get if we divide all the sides of the voltage triangle by I, we will get impedance triangle. Suppose we have this triangle, voltage triangle, and we divide each side by I. If we divide each side by I, then what will happen? This side, which is VR, this side will become only R. I divided this side by I, so this will be only R. This side will be VL by I, so this side will be XL. And divide this side by I, so this side will be V by I, IZ upon I, so this will be equals to Z. If I divide all the sides of a triangle by the same quantity, then angles will remain same, means this angle will remain theta. This triangle which we get is called as impedance triangle. Now from this impedance triangle we get many informations like Z will be equals to under root of R square plus XL square. Pythagoras theorem, Z is equals to under root of R square plus XL square. Second thing, we can calculate power factor. Power factor will be cos theta will be R by Z, base upon hypotenuse. Third thing, if we take the components of Z, we can write R will be equals to Z cos theta. Similarly, XL will be Z sin theta. So these informations we get from the impedance triangle. Similarly, if we talk about the power in various elements, for that we can make a power triangle. In AC circuits, there are three types of powers. One is active power, second is reactive power, and third is apparent power. So, if we are interested in the power in various elements, we can make power triangle. Power triangle we will get if we multiply all the sides of voltage triangle by I, then this side will become VR into I. This side will be VR into I. Or it will be I into IR, that will be I square R. VR is also V cos phi. So I can write V cos phi here, so it will be VI cos phi. This is one of the power. We represent this power by symbol P. This is the active power or called as only power. This is the real power which is useful for many electrical applications. Second power will be, if I multiply this side by I, this will be VL into I or I square XL. VL is also V sin phi, so I can write as VI sin phi. This power is represented by the symbol Q. This power is always there, but it is not of practical use. We cannot remove it, it is always there, but it cannot be used to switch on the fan or for lighting. This is called as reactive power or imaginary power. And the largest power is in the AC circuits is V into I. V into I, which will be equals to I square Z. We represent this power by symbol S. Unit for this active power or real power is watts. This power is in watt. Unit for Q is volt ampere reactive, VAR. And here its unit is volt ampere, VA. I multiplied all the three sides by the same thing, so this angle will not change, it will remain theta. So what are the things we get from here? First is that hypotenuse square equals to base square plus perpendicular square, s square equals to p square plus q square. Second thing, we can also calculate power factor from here, cos theta. Cos theta will be equals to P by S, active power upon apparent power. Third thing will be, we can write P as S cos phi, S cos theta, and Q as S sin theta. So these are the three powers in the AC circuit. Similarly, we can analyze RC circuit, RLC circuit. Just we have to draw the power. Just we have to draw the phasor diagram and make voltage triangle, impedance triangle, and power triangle. Thank you. If you have any doubt, please ask.